Hi Stanford families, it's Miss Ingram here and welcome to the virtual maths workshop. So I'm here to go over some of the things that you need to know about maths at Stanford Infants. So usually if we were in the hall, I would get you all up and out of your seats and we'd do a little Go Noodle to get active. Now the Go Noodles that I have got links for here are all to do with maths. So if you fancy getting up and moving now, go for it. I won't embarrass myself by standing in front of you doing Go Noodle at the moment. I will save that for next time. So we have lots of different ways of getting children involved in maths at school by also exercising. So have a little go at one of those with your children. Now, when we think about maths, I know personally that prior to being a maths lead, I found maths quite scary. So we have a lot of feelings when it comes to mathematics about how we experienced it at school, and sometimes we might project those feelings onto our children. So I've had a little think about how I felt about maths, and I came up with some ideas. So fear of getting it wrong, panic, I don't know what I'm doing, I don't want to get it wrong, so a bit of failure, being scared because I just don't know what to do. But when we're at Stanford, we want to encourage these things. So we want excitement, we want children to feel challenged, we want them to be determined, we really want them to be creative and to have fun. Finally, we want it to be relevant, because otherwise, what's the point of it if we don't understand its relevance to our place in the world? So, we are green mice at Stanford, and we are particularly green mice when it comes to our maths. I'm sure the children will tell you that themselves. So, I'm just going to go over some things I'm going to be covering in this presentation for you. Firstly, the expectations for national curriculum from EYFS through to year 2. The impact that we are seeing on fluency and how we are going to be improving that through our mastery teaching. What maths looks like at Stanford Infants, how we are getting children to be more confident, and also how we can help you to understand the maths that we are teaching, which then in turn will help you to support your children at home. There are then going to be 3 sessions all about maths in each of the year groups, presented by my fellow maths experts. So, when we are exploring the teaching of maths at Stanford and across the whole of England, many maths teachers will be familiar with this, the 5 big ideas of teaching for mastery. So we really think about how we plan our lessons in terms of this, making sure that we are starting with small steps from the national curriculum, and then how we are going to ensure that we teach them, that the children are going to learn them, and then how they're going to use them. So we make sure, particularly with the main sections here, that we are doing these throughout our maths lessons. So often we might recap something that they've done in the previous lesson. We would then give them the opportunity to do a bit of fluency work. We would then expose them to different concepts and procedures through variation. We'd then get them to explore that through representation and structure, and then really get them to make connections with their mathematical thinking by presenting them maybe with some challenges or some problem solving activities. So there is a lot of thinking that goes into our planning for maths at Stanford. And I know that we have worked really hard as a maths team to make sure that the progress from reception to year 2 and the progression is really clear, and that we are really building on each of those learning opportunities year on year. So the national curriculum, which was implemented in 2014, is for maths all about fluency. So we want children to become fluent in the fundamentals of math through varied and frequent practice with increasingly complex problems over time. So we'll explore what that looks like later on. The next part of the national curriculum that we focus on is reasoning. So we want children to be able to reason mathematically by following a line of inquiry, conjecturing relationships and generalizations, and developing an argument or justification or proof using their mathematical language. And again, we will cover some of the things that we do in our workshops of exploring how the children are able to do this. And then finally, solving problems. So after we've done all that fluency, after the children have become confident in their numbers, we then present them with problems to solve. So can they solve problems by applying their maths to a variety of routine and non-routine problems with increasing sophistication? So in each year group, that is outlined in different ways. Now, this here is the early learning goal, the end of reception expectation for the children. So we aim for children at the end of reception to have a solid understanding of numbers and their value. And this is the first stage of them being able to calculate. So we really spend a lot of time reception focusing on those numbers 0 to 10. And it is so important that children practice with those numbers, they make those numbers, they explore those numbers in different contexts, because it's so important in that foundation stage to make sure that they have got a really solid understanding of 0 to 10. And that will help them for the rest of their maths lives. Now, often we find that lots of children always think that having bigger numbers means that they're better at maths, and that is not always the case. We want the children to be confident with the numbers that we are teaching them. So in reception we go up to 20, but we really spend a lot of time on 0 to 10 and then those teen numbers, and that then translates into year 1. So these are some of the things that we cover in year 1, and you will see that some of the curriculum from EYFS through to year 1 is slightly different, and there is quite a huge leap in the expectations from the early years foundation stage assessment to the national curriculum. So we really focus on a number of different aspects in year 1 of mathematics, so not just number. We also do fractions, measurement, properties of shape. We then also explore multiplication and division. And as we work through all of that, we are thinking about what the children will need to know in year 2. And again, they also then explore those concepts of addition and subtraction, fractions, but then they also explore other areas such as statistics. So what we want to do throughout Stanford is make sure that the children are having the opportunity to achieve all of these curriculum aims, but really building up their confidence with it. And that really starts in reception, and we continue to build on that throughout their time here. So the end of year expectations, when we assess the children, which may be slightly different given the pandemic and thinking about what the children may have missed out on, we would see this written maybe in their reports at the end of the year. So in reception, they would either be emerging, expected or exceeding, and in year 1 and 2, we would see working towards expectation, working at expectation, and working at greater depth. Now, these are the terms that we have to assess again, but obviously we think about each child individually and what they are achieving, and for them, what they are doing that is a really positive in their mathematics. So we look at their progress, we don't always look at where they end up in comparison to each other, because every child is unique. Now, I did say we were going to talk about fluency. Now, this is an area that we've worked on, particularly last year, and we're continuing to think about. So when we talk about fluency, it's often a bit like our mental maths that we used to do at school when we were younger. So fluency is being efficient, accurate, and flexible. So it's basically being able to use numbers, represent them in different ways, and understand what happens if we manipulate them. So it's a deep understanding of low numbers. So to be fluent, and I will share with you my fluency grid, it is important that children understand what happens to each of those numbers from 0 to 10. And that is the key to fluency. If they understand their number bonds, if they understand their number facts, then their fluency will increase in efficiency, and they will also be much quicker at being able to recall number facts. So when they've got that deep understanding, they will then be able to write and understand how numbers are made using different objects. They will have a solid knowledge of 10 and 0 and how they work in our number system. So for example, understanding that 0 can be a placeholder and understanding that 10 can be made out of ones and really exploring that. We then want them to make sure that we are giving them the chance to do addition and subtraction as well. So the 4 operations are addition and subtraction, but we also, as we move up the school, will present them with division and multiplication, and that gets more complex from year 1 through to year 2 and beyond. We really want them to understand the relationship between those operations, so understanding that addition and subtraction are the inverse of one another, and that is the same for multiplication and division, and then using the facts that they know about them to be able to work out different problems involving them. We want them to be able to use a variety of calculation methods, so written methods, mental methods, things that they're going to be able to use in objects, pictures, all of the different ways that we can represent our mathematics. And we want them to have a solid understanding of equality, which means that they understand that that equal sign that we use is also meaning the same as. So it doesn't always mean that that's getting us the answer. It just means that whatever is on one side of the equal sign is the same as what's on the other. So to think about fluency like this, we think about how fast a person can retrieve correct maths facts from their working storage memory. So we are getting it from our working memory that might be thinking about all our maths facts, and then making sure that we are keeping that knowledge in our brains and storing it in a long-term memory so that we can keep practicing it, which is why we do lots of fluency daily and why we encourage you at home to have a look at that maths fluency grid. So when we're thinking about that, we want the children to be practicing that as much as possible, but in short spurts each day. So it could just be 10 or 15 minutes every day practicing things. It could be practicing your number bonds. It could be singing a song about your number bonds. It could be practicing your times tables. All of that is time well spent in fluency. But it's really important that even if they are remembering and then recalling them, they do have to understand the underpinning maths that actually enables them to understand how they're getting those answers. So they need to understand how and why, when they put two numbers together, it makes another number. Okay, so practice, it really is important with that. So these are the 3 main elements that we have when it comes to fluency. So efficiency. So this implies that children do not get bogged down in too many steps or lose track of the logic of the strategy. An efficient strategy is one that the student can carry out easily, keeping track of any sub-problems and making use of intermediate results to solve the problem. Accuracy depends on several aspects of the problem-solving process, among them careful recording, knowledge of number facts, and other important number relationships, and double-checking results. We really encourage the children at school to double-check their answers. We always say to them, "Are you sure?" And often they look at you as if to say, "Well, I've done it." And we say to them, "You've got to check it and check it again just to make sure." Because often when you say that, it grows a little seed of doubt in their mind, but that seed of doubt is encouraging them to make sure that the answer is correct. And it's very important that they become the teachers to themselves and are checking and correcting their own maths. And then finally, we've got flexibility, which requires a knowledge of more than one approach to solve a particular kind of problem, such as 2-digit multiplication. And students need to be flexible in order to choose an appropriate strategy for the numbers involved, and also be able to use one method to solve a problem and another method to then check the results. So having that flexibility to really use different methods in their mathematics. And this isn't just for Key Stage 1, this is also all the way up to Key Stage 2. So everything that we are putting in place in these 3 years at Stanford will really help them in the long term when they are at junior school. So fluency demands more of the children than just memorizing. So they need to understand why, what they are doing, and what they are doing, and know when it's appropriate to use different methods. So often we think about when we are doing maybe something like column addition and working out, is that the most efficient method to be using to get the answer the quickest? And that's the same when it comes to doing mental arithmetic in our minds. So what facts do the children need to be able to recall? So for many of them, it is counting forwards and backwards, then number bonds, addition and subtraction facts, 1 more and 1 less, 2 more and 2 less, or 10 more and 10 less. So playing around with those numbers. We also want them to be able to double and halve, and to use those double and halves to find near doubles. So for example, if I know that double 4 is 8, I will know that 4 add 5, which is 1 more, must be 9. And then finally, our skip counting, which you might remember to be counting in 2s, 3s, 5s and 10s, like our times tables, but often not just counting in 2s, 5s, 3s and 10s from particular numbers, but from any number in the number system. So this is our practice makes progress maths table. So this is our fluency grid, and we have these at school, but they are also available on the website. And it is really important that you see that these are the facts to concentrate on when I'm talking about fluency. So there is a little section that you can see highlighted from up here, which is to do with this area, these little steps here. This is for year 2. But the rest of it is everything that we cover in year 1 that we teach to the children and we try and practice daily. So the colours coordinate to each of the mathematical aspects that we try and teach. So you can see that those yellow parts are our number bonds to 10. The purple bits are when we are adding 10 to a number. So we really want the children to be able to understand each of these aspects so that they become more fluent. And once they get all of these, they'll be able to do so much more with their maths. So at any point you've got any spare time, have a go, see how quickly they can recall it. Now, when we want them to recall it, we want them to try and avoid using things like their fingers and writing things down. We really do want it to be coming from that memory storage. So having a go at, you know, recalling a certain amount of them at a time, so focusing mainly on just number bonds to 10, would be a great start rather than try and do all of it at once. And it's not just something we want them to do once, we want them to do it again and again and again. So they might know 4 plus 6 is 10 today, but tomorrow they might not, which means it is not stored in their long-term memory bank, which means they need more practice. So as it says at the top, again, practice makes progress. So the main thing that we want children to do is to be confident with their maths, because I know how hard it was not feeling confident about maths when I was at school. So we want to help the children to do that. So when we are thinking about that, our starting point is obviously in the early years, and early maths and subitizing is a really key skill. And this is where we become really familiar and are able to process immediately objects that are in small groups. So for example, we have a dice here, and we know just from looking at it that that number here is 5. And that is what that mathematics is about. So it's a familiar and structured dot pattern. It doesn't always have to be dots, but it's a pattern that we are familiar with, that we know is 5. That's ingrained in our memories. So we want the children to become familiar with that by exposing them to different things. So we have a structured pattern here. We have another structured pattern. So again, we can see that this is 4 and 1, which must mean it's 5. And then we've got unstructured patterns, which we then might create ourselves into groups. So I can see here that there are 3, and then there's 2 over here. So then I would again know that that is 5. Now, the main starting point with all of this is place value. And we spend a lot of time, particularly in the autumn term, looking at place value. And place value is at the So place value is at the heart of our number system. All digits have a value, and a secure understanding of this will enable children to use and understand different calculation methods. So often we have that misconception, as I said previously, oh, you know, my child can count to 100, which is absolutely fantastic. But do they understand the value of the digits that they are counting, and can they represent them? And that is where place value is so important in helping children to understand all those 4 different calculations that we do in addition, subtraction, multiplication and division. So place value really is key. Now, my favorite thing, keep counting. So just remember that all these different things will help your children with their maths fluency and their confidence. Now, the other part of the curriculum aims, as well as fluency, was the reasoning. So reasoning in maths helps children to be able to explain their thinking, therefore making it easier for them to understand what is happening in the maths they're doing. It helps them to think about how to solve a problem, explain how they've solved it, and to think about what they could do differently if they were to do it again. So for example, true or false, if I add 0 to a number, it makes it bigger. So their reasoning about this could be to do with their knowledge of the place value system, whether they are using 0 as a placeholder, if they are putting 0 in a particular column, if it's going in the ones or the tens or the thousands. So it's really about thinking of that knowledge that they've learned through their fluency and then being able to use it in different ways. So this then helps to lead on to understanding their mastery. So a child has mastered or understood something if they can do these things. So firstly, describe it in their own words, represent it in a variety of ways, explain it to somebody else, including you grown-ups at home, make up their own examples of it, see connections between it and other facts or ideas that they may have been exposed to, recognize that mathematics in new situations and contexts, and then make use of it in a variety of ways and new situations. So all of these things help us to know if a child has really understood and mastered their mathematics. So if you're ever at home wondering, oh, can they really do it? Do they need an extra challenge? Try and see if they can do all of these things. And this is obviously a famous quote from Einstein: if you can't explain it simply, you don't understand it well enough. So the children need to be able to explain it to show that they have understood it. And that's where we will use things like STEM sentences to support them with that vocabulary. So when we're teaching for mastery, we choose to teach by breaking down the maths into small steps, as I said earlier. So we want every single child to be secure in all the concepts that we are teaching before they move on. We do not want to move them on too early because that creates gaps in their learning. We focus upon teaching the fluency, the reasoning and the problem solving that I have just covered. So you can see down here, the answer is only the beginning. So I really want to keep going with that maths. So when we are exploring our maths, we're not just trying to get the answer. What we want the children to do is to tell us how they've got there. What have they done? And to be able to do that, we use 3 different approaches. We use the concrete, the pictorial, and the abstract. If you want to know more about those, I'm going to come on to it now. So at Stanford Infants, we use the CPA approach for teaching and learning in maths. So this is the concrete. These are representations where we would use concrete objects. There's the pictorial, where we would use pictures to represent. And then there's the abstract, which is the numerals that we would put in number sentences and the mathematical symbols. This helps us to teach concepts in different ways and to help build on the children's understanding. So this is an extract from our calculations policy, which can be found on the website. So this is how we would explore the same concept using different parts of that approach. So this is the concrete, and we're looking at combining 2 parts to make a whole. So you can see we've got resources to support their understanding. So we've got some tubes where you put one number down, another number down, and then you would find the whole at the bottom. What does the number make? You would then use our part whole model to share how that number is made by looking here. We've got 6 cubes. Here we've got 4 cubes. that means we must have 10. And then finally, again, representing it using these cubes as well. So getting those children to really physically use the mathematical resources to show their understanding. And alongside that, we use our STEM sentences, which gives the children the vocabulary to be able to explain and master that maths. So here is one example. 10 is the whole, 6 is the part, 4 is the part, and 10 is the whole. Then as we move on, we then come to our pictorial representations. So it looks similar, except before we were using objects. Now we are using pictures to show those models instead. So whereas I could usually have counters to be showing my part, whole model here, instead I've drawn circles. So here you will see that 7 is the whole, 4 is the part, 3 is the part, and 7 is the whole. So lots of repetition to really get that language embedded in the children's brains. And we could also do the same with this bar model and this bar model here. You can see the STEM sentences that are next to them to help the children to explain what is happening. And we want to make sure the children are able to see different ways of showing their mathematical understanding. And once they've done this, we are then able to encourage them to use the abstract, which is the numerals that show what is happening to the number sentences. So the pictures disappear and we replace them with numbers. So you can see that we still got 7 here, but the number 7 is represented in its numeral. So 7 is still the whole, 4 is still a part, 3 is a part, and 7 is the whole. And then from that, we encourage the children to expand their learning by thinking about, well, how many number sentences can we get from this? And exploring that in different ways. We often show the children not just this way of writing a number sentence, we also show them this way. And that is why it's so important that the children understand that this symbol doesn't just mean that we are finding an answer. It means the same as or equal to. So we would say to them, 4 add 3 is equal to 7. And then we'd say the same for these ones. We'd say 7 is equal to 3 plus 4. So there really is a lot of maths that you can get out of the children when really exploring their understanding. Now, we've talked a lot about number in this, but obviously we do explore other areas of mathematics, and some children really enjoy doing work with shape and measuring and statistics, and it's all just as important to make sure that they are having the opportunity to explore money, to weigh things out when you're cooking, to measure their feet as they are growing or themselves as they're growing, and be looking out for shapes on a shape hunt. So please try and make maths part of your day, because we do use it a lot more than we realise. Now, these are some of the resources that we use in school. You can have a little look there to see which ones are useful. You can get lots of these online, but you can use a lot of things at home instead of buying resources, okay? So for example, we've got tens frames, and you could print off a tens frame from the internet and use objects from home instead. You can draw bar models. If you don't have counters, you could use coins, you could use pieces of pasta. Do not feel pressure to go and buy anything. There are lots of ways that we can represent our maths with resources. So I expect you're wondering how you can help your child at home. Now, any time that you spend supporting your child is worthwhile, because it will have a big impact on their maths. So we want you to make sure you're talking about how you do maths. Explain to them that when you were at school, it was a little bit different, or you can show them how you do it. It won't confuse them. It just makes them understand that there are different ways of learning and different ways of talking about maths. We want you to be as positive as you can. Now, it's hard when you've had a hard time at school and not really got maths like I did. But now that I really understand it, it's a lot easier to be more positive about it. And I'm hoping that by sharing what we do at Stanford Infants, you all now understand better how we teach maths and how you can actually understand it alongside your child when supporting them at home. Make sure you ask them to explain, okay? Explain to you, show it to you. So that's really mastering our learning that way, by making sure that we're giving them the opportunities And it is tempting sometimes to tell them what the answer is or to show them how to work it out. But sometimes we do just need to take a step back and just say to them, right, have a go. What are you finding out? And then if they've made a marvelous mistake, it doesn't matter. That's how we can learn new things. We also want you to give them praise, encourage them, which I'm sure you all do. And just to notice that maths is everywhere. Like I said earlier, it is in our lives and it is here to stay. So make maths fun. Now, on top of all that, there are some other things that you can do. So everyday maths, look for patterns, spot numbers, look at doors. You know, when we're allowed to go shopping again, do some addition with prices, tell the time, see if when they're doing their remote learning, if they can tell you how long they've been doing something for, have a go at some of the maths challenges that we've got on our website as well, and that will really help with those things. Make sure you're practicing times tables. This is more for year 2, but counting in 2s, 3s, 5s and 10s is helpful for all children, as long as they are confident and they understand what those numbers mean. And try and ask open-ended questions. So things like when we're saying, I'm thinking of a number, and getting them to ask you questions that can then explore what that number might be, or saying to them, the answer is 20, what might the question be? Board games, fantastic time to spend as family, playing board games, cards, and then there are plenty of resources online, for example, number blocks and number jacks, which are on CBeebies, but there's also other things now available following the pandemic that people have developed. So do search out there. There are lots of useful resources online. And when we are allowed to be playing outside, there's lots of things like Skittles, hopscotch, and even children making up their own games that helps them to get involved in maths. So we also have stories too. Sorry, I missed that at the bottom there. We've got some stories. So 1 is a snail, 10 is a crab. If you search on Amazon mathematical stories, it will come up with a whole load. And I know that on Waterstones, they do the same too. Now, you may have noticed in December and January, we put on a Maths Mastery calendar for each year group. These are going to continue throughout the year. So if you do finish your remote learning and you want something extra to do, or you get home after a day of school and want an extra challenge, there is a daily maths challenge for every year group. So please have a look at these on the school website. And then there's also a variety of apps, workbooks and websites to support that learning at home. If you want to have a little look and write any of these down, then please pause the video here. And as well as that, I've provided you with some links to some of the websites that we use in the school. There are more of these available on our website. So thank you very much for listening. I hope I haven't taken up too much of your time. There is going to be virtual group workshops, one with Miss Wild from reception. I have done one for year 1 and Miss Holiday has made one for year 2. So please enjoy watching the ones that meet your family's, your child's year group, sorry. And final thing, we are introducing all families, and you will have been invited today to Numberbots, our new online number game to help develop fluency. I will do a short little video of what that is later on. Thank you very much. I hope you enjoy exploring and having fun with maths.